This video will cover a very popular rule in calculus called LHospitals Rule. This will allow us to find certain limits in a much easier fashion than otherwise. I do have a fun little story I always tell about LHospitals Rule, is that the person named L'Hopital, who is named after, turns out he did not actually create this rule. There was another mathematician by the name of Bernoulli that was his tutor, and L'Hopital was kind of a rich person, and he paid Bernoulli in order to take credit for this. And so now, hundreds of years later, we call it L'Hopital's Rule, even though he's not the one that invented it himself. So it's kind of a fun little historical fact here. Now let's get down to it. So the idea is, whenever you have a limit of a fraction, and if you try to find top and bottom, and you either get 0 over 0 or infinity over infinity, then it turns out that's a L'Hopital's Rule case. It's called an indeterminate form. And what you are allowed to do then is you are allowed to find the limit by taking the derivative of top and bottom separately, and then finding the new limit of something that's hopefully simpler. And as long as that new limit actually works out, then it's going to give you the same answer as the original limit. Now let's go ahead and look at this first example here. If I try plugging in 1, I'd have 1 minus 1 over 1 minus 1. I'd get 0 over 0. Now 0 over 0 is undefined. I can't just write the answer down. And you could find this limit, you could find it by factoring. So you could say, okay, I can factor the top and the bottom here, and then I don't know how I can factor the top, a bunch of other stuff here, and then you'd be able to cancel it out, and then you'd be able to plug it in and try to figure it out what the answer is. But the problem is, that's a real pain. And maybe you don't know off the top of your head how to factor x to the 10 minus 1. Well, then you'd be stuck. However, what we can do instead is use L'Hopital's rule, where you say, okay, what is the derivative of just the top one? Well, x to the 10 minus 1 would go 10x to the 9, and that's your derivative. Then we'd say, what's the derivative of the bottom one? X squared minus 1 is going to be 2x. Well, in this case, by taking the derivative of top and bottom separately, I then can simplify this to get 5x to the 8th, and you can plug in 1 there, and we get the answer 5, which is correct. So you see that L'Hopital's rule allowed us to find this limit without having to do any crazy factoring or algebra. We just take derivatives top and bottom, and we're going to get the answer. Okay. The next limit here is going to be something similar. And we have the derivative, we have limit as x goes to 0 of e to the 5x minus 1 over x. And if we plug in 0 for top and bottom, we'd have 1 minus 1 over 0 is 0 over 0. So therefore, can't actually plug it in there. But this is the right type to use L'Hopital's rule on. So we go ahead and take derivatives top and bottom separately. The derivative of e to the 5x minus 1 is going to be 5e to the 5x. The derivative of x on the bottom is 1. And we can just go ahead and plug in 0 here. 5 times 1 over 1. And we get the answer 5 again. So again, you see that we had a limit that wouldn't be possible just to plug in. And this time, there is no nice factoring you can do to cancel out the x on the bottom. So you're going to be really stuck here. However, we can use L'Hopital's rule and get the answer right away. The third example here is going to show a slightly different situation where if you plug in infinity, in some sense, x squared on top would go to infinity, e to the x would go to infinity, you'd have infinity over infinity here. Well, infinity over infinity is also an allowed case for L'Hopital's rule. So that means we can go ahead and apply it here. And we say, okay, what's the derivative of the top? Well, the derivative of x squared is 2x. What's the derivative of e to the x? Well, e to the x. And this is going to be now a simpler limit to deal with. Of course, if I go to infinity here, I'm actually still going to have infinity over infinity. So you might say, well, oh well, I guess that means we can't use L'Hopital's rule. We have to make sure that this limit actually works in order to use L'Hopital's rule. But it turns out that if you do your L'Hopital's rule once, and you are still in 0 over 0 or infinity over infinity, then it turns out you can actually keep using L'Hopital's rule as long as it's always in one of those formats. And if eventually the limit works, then that's going to be the right answer. So I can just go ahead and use L'Hopital's rule again here. Derivative of 2x is 2. Derivative of e to the x is e to the x. And so if you think about plugging infinity, you have 2 over infinity here. Or in other words, you have a number divided by a really, really big number, and you're going to get 0. So again, L'Hopital's rule can be applied multiple times. And you can do it, 2, 3, 10 times possibly. Sometimes it's not a good idea to keep doing it that many times, but it will work. Now this last one over here, this last one is a little bit different because you see there's no fraction there at all. It's actually two things multiplied by each other. Now if x goes to 0 on the first part, you get 0. And if x goes to 0 for the natural log, that's going to go to negative infinity, right? Look at the natural log graph here. So we have 0 times infinity, but that is not one of my allowable formats to use L'Hopital's rule. And so what we're going to do then is we're going to play around with some algebra here to make it into a correct form for L'Hopital's rule. And all you have to do is move one of them to the denominator. I'm going to choose to move the x in front to the denominator, so it's going to become 1 over x there. And if you then look at this, we're going to have a negative infinity over infinity case. So now we are allowed to use L'Hopital's rule. Derivative of natural log is 1 over x. Derivative of 1 over x is negative 1 over x squared. And that's going to simplify down to just negative x. And as x goes to 0 here, we're going to get 0 as our answer. So I just want to show you that L'Hopital's rule only directly applies to 0 over 0 or infinity over infinity, but it is possible to use it on other situations as long as you can convert it into that format in some way.